Okay, so today we're going to talk about balancing chemical equations again. This is part two. So part one was kind of the easy introduction lesson. So now we're going to start doing more advanced stuff, but basically going to do the same thing. So again, it's a good idea to leave some space when you write out these equations so you can write in the coefficients and change them as needed. Again, you cannot change these subscripts. You can only change these coefficients, the numbers in front of the molecules. Okay? So again, what I'd like to do is put each molecule under the yield sign. So we have some nitrogen and we have some hydrogen. So that's it, just two atoms. So how many nitrogens on the left? Right now we have two, diatomic. And how many hydrogens? Again, two. Again, also diatomic, right? So the left side is done, the reacted side. So what about the product side, the right side? So how many nitrogens? Here we have one. How many hydrogens? Three. So are we balanced? No, we are unbalanced on both atoms. Nitrogen's unbalanced and the hydrogen's unbalanced. Now usually what you want to do is get rid of any odd numbers because those are usually where you're going to find the problem. So we kind of have a choice, the 1 or the 3. Usually 1's not as bad, 3 is usually pretty bad, so let's get rid of this 3. Easiest way to do that is put a 2 here, right? So now, again, that changes everything on the right side, the number of nitrogens and the number of hydrogens. So how many nitrogens do we have now? We now have 2, right? But that also changes the number of hydrogens. So now we have 2 times 3, so now we have 6. And so the good news is the nitrogens are now balanced, but the bad news is hydrogen is still unbalanced. So now we need to increase the number of hydrogens on the left side, on the reactant side. So obviously we need to put a number here, because putting a number over here is not going to change the number of hydrogens. So what number do we need to put here to get 6 on the left, just like on the right? So we need to put, what, a 3? Because 3 times 2 is going to give us 6 hydrogens. So now we are completely balanced. So the coefficients are going to be 1, 3, 2. Okay, so let's maybe do a more advanced problem now. Or about the same level, maybe. Let's see, we have, again, space, HGO, so it's mercury oxide, space mercury, plus space O2. All right, so again, let's put the atoms down the middle. So mercury and oxygen. How many on the left? 1 mercury, 1 oxygen, that's pretty simple. On the right, 1 mercury and 2 oxygens. Okay, so again, we're unbalanced, so we need to change the number of oxygens on the left. We've got to increase that, so we can put 2 here. But again, that changes everything, the number of mercuries and the oxygens. So now we have 2 mercuries on the left, and now we have 2 oxygens on the left, so those are balanced, that's good. But now the mercury is unbalanced, so now we got to change that. So we got to change the number over here. So we got to put a 2 there, because then that will give us 2 mercuries, and now we're balanced. So 2, 2, 1. All right, so let's do another one. So hopefully you guys are catching on to that. So we have, let's see, space, zinc, plus HCl, hydrochloric acid, that you should be familiar with, yields zinc chloride. I don't think I gave myself enough room here, plus space hydrogen. Okay, so I kind of crammed it up there, but okay, so we can do the same thing. So I'll put the zinc over here now. Zinc, hydrogen, chlorine, right? So on the left we have right now 1 zinc on the right, 1 hydrogen on the left, 2 hydrogens on the right, 1 chlorine on the left, 2 chlorines on the right. So clearly we're unbalanced. So zinc's balanced, hydrogen's not, chlorine's not. So now we clearly need to change the left side. We got to increase these numbers. So one way to do that is put a 2 here. We got to increase the number of hydrogens. So now we have 2 on the left, 2 hydrogens on the left, but we also have changed the number of chlorines. So now we have 2 chlorines on the left as well. And that pretty much balances us out. So now we have, that's a 1. 1, 2, 1, 1. All we had to do is put a 2 there, basically. Okay. So let's maybe do one more. So let's do sodium plus water gives us sodium hydroxide plus hydrogen. Okay, the same mistake, but it's okay. So let's put all of the atoms down the middle. So we have sodium, hydrogen, and oxygen. All right, so how many sodium is on the left right now? We have one on the right as well. We have 2 hydrogens on the left. We have 3 hydrogens on the right, 1 oxygen on the left, and 1 oxygen on the right. So what's unbalanced? The number of hydrogens. Sodium and oxygen are okay. But again, when you have an odd number like 3 or 5 or 7, usually you want to get rid of that because that can be the problematic number, basically. So how can we change that? It wouldn't do us any good to put a 2 here because then we have 4 plus 1 is 5. So you don't want to change this because that's going to be even no matter what, whether you put a 2 or a 3 here, right? So here, this is the problem. You have 1 lone hydrogen, so we want to put a 2 here because then we get 2 hydrogens. But another 2 here would be 4 total on the right, so this 3 becomes a 4. So 2 hydrogens here, 2 hydrogens here is for a total of 4. Okay. So now we got to change what? The number of hydrogens on the left. So we have 4 on the right, we need 4 on the left. So we can change that by not putting a number here, but now we need to put a 2 here because 2 times 2 is 4. So now we have 4 hydrogens on the left, but we also change the number of oxygens when we put a 2 here. So the number of oxygens is now 2. So unfortunately, that means now we're unbalanced on oxygens on the right. Although actually I just realized I forgot to change these numbers actually. Okay, so let's change those numbers. So we have 2 sodiums here and 2 oxygens there. So actually now we're almost completely balanced. So now we got to change the sodium on the left. So put a 2 there. And there we go, we appear to be balanced. Just don't want to double check that and make any mistakes. So I think that's it. Right, so 2, 2, 2, 1. Yeah, sorry about messing those atoms up. I forgot to redo those numbers. So every time you do that, you want to redo those atoms. So yeah, okay.